conservator with experience in preservation projects throughout the United States. She's also the senior lecturer at the University of Texas School of Architecture, where she teaches materials conservation and is the director of the Architectural Conservation Laboratory. Fran works with the UT Office of Campus Planning and Facilities Management on projects involving historic buildings and monuments on UT's campus. Fran earned her master's degree in historic preservation from Columbia University. She is an AIC professional associate and is the associate editor of the AIC journal since 1995. Fran is also an active member of the Association for Preservation Technology and a member of the APT College of Fellows. Fran?
Thank you, Mary. I think it's going to pay off to be short because the microphone seems to fit me perfectly. So, sorry, tall people. Good morning. I'm pleased to return to the city of Fountains, where I lived and worked for 8 years. And our keynote speaker, Jocelyn, what a debt of gratitude all of the rest of us speakers owe to you for really setting us up perfectly. I'm the first of several speakers who will discuss maintenance of historic fountains. And in preparing my presentation, I was struck with the range of work that's involved with maintaining fountains. And I expect that I and the other speakers will discuss the roles of conservators, landscape architects, water specialists, engineers, and when I say engineers, civil, structural, MEP, all of those professionals are responsible and have a role in maintaining fountains. I'm going to begin by discussing what I think are the essential components of a maintenance program. Inspections, cyclical maintenance, prioritized work, and annual reports. And again, thank you, Jocelyn, for setting me up. I can refer to my own projects and some that you've tackled as well. Those of us who've worked in the field for years know that there are really great resources out there that discuss maintenance. We have preservation briefs, we have conservograms, we have checklists, guidebooks. A resource that I have found particularly useful is Dale Friends' chapter on establishing maintenance programs that is a part of the book Caring for Your Historic House. And actually I have found his discussion of maintenance to be useful for monuments and fountains as well. I hope you will too. To illustrate the requirements for a comprehensive maintenance program, I'm going to discuss the fountains that grace the University of Texas at Austin campus. And as Mary indicated, in addition to my duties as senior lecturer in the School of Architecture, half my job is with facilities services. And that's a campus organization whose mission is to, and I'll read, create and manage a physical environment that promotes learning, research, and public service through core values of service, integrity, teamwork, excellence. So a lot of lofty goals for facility services. Their work includes building maintenance, custodial services, landscaping services, equipment repair, preventive maintenance, and you can see from the range of activities that facility services is involved with, they're really the perfect stewards for the 14 fountains on our campus. We're kind of a little microcosm, I think, of what Jocelyn described for the City of Kansas City Parks and Recreation Department. One thing that I haven't encountered is refuse from meth operations. I don't envy you that. From my office window, I can see Goldsmith Hall, the architecture building, and the courtyard pool, designed by Paul Cray in 1932. And as part of my job with facility services, I have sort of a vague job description. I think part of it is to answer the phone and do what anyone asks me to do. And oftentimes that is to dig into the campus archives and learn about the history of our campus, and that has certainly involved fountains. But it provides an opportunity for me to explore the architect's intent, early design schemes, and you see on the right an early design scheme by Paul Cray, his sketch for the architecture courtyard pool. Learning about the development of the UT campus has been a really rewarding part of my work. And you can see that the UT fountains range from very simple to very elegant. The first slide with the Littlefield fountain is probably the most ornate, and I'll get back to that. But we certainly have other fountains that range from those that were part of the 1930s campus plan when Paul Cray was the campus architect and planner. Mary Gearing Hall, you can see a fairly simple fountain that is in the courtyard of that building. Flan Academic Center from the 1960s has a sculpture by Charles Umlauf and a small fountain that you can't see it now, it's not on, but the water is behind the bronze sculpture. And then recent additions, including a fountain that was part of a 2010 renovation of the courtyard at the Texas Union, the Student Union. In my view, each of the fountains is really intended to promote a moment of reflection, a time of quiet thought on a campus that is really bustling with activity 24 hours a day. I'm going to use the Littlefield fountain, and as I mentioned, it's probably the most elaborate of the fountains to discuss the essential components of a maintenance program. And I'm leading with two photos of the Littlefield fountain. The first is a photograph, historical photograph, that really captures that fountain at a particular moment in time. The fountain was finished in 1932, 2 years before the original old main building was raised. Paul Cray designed the new main building, which is the UT Tower that you see in the photograph at the bottom of the screen. But the photographs I included to really show you how important the Littlefield fountain has been on our campus since its construction in the 1930s. The Littlefield fountain was funded with $250,000 from a trust that was established by Major George Littlefield, an early patron and pretty strong-minded individual. The artist is Pompeo Copino, an Italian-born artist. He was the sculptor, and Paul Cray, the architect, and I might mention sort of the late arriving architect, Cioppino had been working with Littlefield on a scheme for the fountain really since the 1920s. The fountain commemorates the 97 UT students and alumni who died in World War I. And the sculpture is composed of 3 seahorses, 2 of which are ridden by tritons, and they pull a ship bearing Columbia, who holds a torch of liberty in one hand and a palm frond symbolizing peace in the other. And she's accompanied by a soldier and a sailor. The design was not without controversy, and in fact, George Littlefield originally envisioned a monument to the Confederacy, and I think now UT is collectively sort of emitting a sigh of relief. In fact, on our campus we have statues of Robert E. Lee and other Confederate heroes, and we're not quite sure what to do with them. And I think the answer to controversial, unfortunately, the answer sometimes is, well, let's just not maintain them and see what happens. Another bit of the controversy stems from Paul Cray's involvement, and he really wasn't pleased with the scale of the fountain, and in fact redesigned the water basins and terrace. Nevertheless, the Littlefield Fountain is an icon on campus and probably one of the most photographed structures that you'll see. It's on axis not only with the main building but also with the state capitol, and does form a gateway to our campus. So back to the components of maintenance programs, and I think that they begin with on-site assessments or inspections to document existing conditions, and in fact inspections, and it should be plural because you can't do an inspection and expect it to last in perpetuity. Inspections should be regularly scheduled. At UT, we have a system for inspecting buildings on a 3-year cycle, and the inspections are done by an outside party. With fountains, it's not as well established, but certainly as part of a maintenance program is highly recommended. Inspections, who should conduct them? Well, I think if you have in-house staff who are skilled in conservation, engineering, landscape architecture, it's fine to have the inspection done in-house, but oftentimes the inspection is best done by in-house staff working with outside specialists. Certainly things like infrastructure, water quality are sometimes better done by outside folks. I think one of the important aspects of inspections is that they do provide baseline information about conditions and are really helpful in identifying work that needs to be done now and as part of a routine maintenance. And it also helps include conditions that require monitoring. So with the Littlefield Fountain, that initial inspection triggered a major restoration effort that lasted for a couple of years and was quite costly. And with the Littlefield Fountain, the inspection provided really incredibly important information about work that needed to be done right away. And as you can see, some of the work included cleaning up the granite, the basin leaked and cracks need to be repaired. The pipes were in pretty bad shape from mineral deposits. They needed to be cleaned. They were retrofitted and lined with a system to help prevent corrosion. The pumps were quite old, and many needed replacement, and a system was installed to filter the water. So quite a lot of work that involved setting things straight following the original inspection report. Since we have lots of conservators in our audience, I'll provide a little bit more information about the bronze conservation that was part of that original restoration work. It was done by John Dennis, who's a sculpture conservator based in Dallas. He actually works with the Dallas Museum of Art. And his work included pressure washing at 3,200 psi, using a wax mixture that was pigmented. It was applied by heating the surface and applying the wax. He actually had to drill holes in the bronze to release water that was trapped within it, and he applied Incrolac over the bronze to protect it from corrosion. His work was well received. The scheduling of it was such that the bronze conservation work was done, and then the entire bronze sculpture needed to be covered while some of the other work was carried out. Record keeping, and again, I think Jocelyn mentioned how important this is. It really is an essential component of maintenance programs. And as far as the work that was done with the restoration efforts at Littlefield Fountain, there certainly are, really pages and pages of information about the materials and the equipment that were used, very specific information, including material safety data sheets, product literature, project manuals, a lot of information about what was used and how it was used. Record keeping also should include personnel who is involved with doing any sort of maintenance work or restoration work, and in this case, there were a number of players, certainly the folks at UT, Project Management and Construction Services, a contractor who did the granite cleaning and repair, plumbing repair work, MEP work, landscape architecture, and again, John Dennis with bronze conservation. Another important component of maintenance programs is cyclical maintenance. And one would hope that cyclical maintenance would be called out in the inspection reports. Certainly following inspection, you have the best opportunity to really hone in on the things that should be done and establish a schedule for when and how often these tasks should be accomplished. Many cyclical maintenance tasks can be carried out by in-house staff, but that said, I would underscore the importance of having written procedures, a list of appropriate materials and products, and forms for recording the work that was done. Certainly, if you have a form, it's much easier than asking a maintenance person to write a flowery report of the work that was carried out. One of the things that, as a conservator, I was pleased to see was that John Dennis's detailed report provided information about the recommendations that were in place for the bronze sculpture, including the materials that he recommended, the schedule for carrying it out, and the procedures with photographs showing how this work is best accomplished. And most conservators, I think, are willing to help train maintenance staff, because I think we see that folks who work for the organization certainly have the skills to carry out many of the things and are best able to do that on a regular basis. Prioritized work is another important component of maintenance programs. And how do you plan prioritized work? Well, I think by definition you can't. Prioritized work is work that is often unexpected. I mean, certainly we know at the University of Texas that every fall before a certain football weekend, we are likely to see graffiti related to Texas A&M. And right on schedule, we had that last fall, 17 instances. And what you want to do is plan for prioritized work such as graffiti removal by knowing who is going to tackle the work, what materials are appropriate for granite, what materials are appropriate for limestone and bronze and so forth, and the tools that should be used. My work with facility services in an emergency situation basically is to take one tool out of their hand and put a safer tool in their hand, take a material out of their hand, a product, and put a safer material in. Because when you have a situation like this with graffiti, the maintenance staff is keen on getting it off and getting it off immediately. And I've listed a couple of categories of prioritized work. Certainly health and safety issues, environmental concerns, things like water issues that Jocelyn indicated, security issues, equipment malfunctions, and nuisance conditions such as graffiti. Annual reports. And annual reports, the smiling fellow in the photograph is Charlie Cromartie, and I met with Charlie and had a really terrific discussion about fountain maintenance. It's Charlie's job to be in charge of maintaining the 14 fountains at UT, and so he really oversees all the work that's done on fountains. And certainly annual reports of the work that's done on each of those 14 fountains helps Charlie establish costs and plan budgeting, try to figure out the staffing requirements, document materials and procedures, and really will help him prepare for prioritized work as well as cyclical maintenance. Skills required. And I mentioned this at the beginning. I don't know of a, I think that the skills that are required for maintaining fountains are really almost as diverse as those for historic buildings. Plumbers, civil engineers, MEP engineers, water chemists, landscape architects, conservators. It really does require quite a community of folks. I wanted to end with just a couple of, we all have unusual situations, and I wanted to end with a couple of quirky problems at the University of Texas that are, in my view, interesting, and they certainly keep us intrigued with maintaining fountains. And I'm starting with a problem that I see as being unfixable. And it has to do with the selection of materials. This is an attractive fountain. It's the East Mall Fountain, another gateway fountain on the east side of campus. And it was done in the 1960s. It takes advantage of a change in grade. There's a pool at the top level, and the water cascades over this granite wall and enters another pool. It's an attractive fountain. But the material that was used to construct the fountain is a South American granite that had an iron mineral that was not stable when exposed to water. And so when water cascades over that granite, the unstable iron mineral corrodes. And thank goodness the colors for the University of Texas are burnt orange and white, and so I think it's seen as being fairly acceptable. Actually, my involvement was in 2001, before I started my job at the University of Texas. I was called in and asked how to clean the granite, and at that point I said, well, I can help you clean it, but it's going to corrode again, and we're going to get this same issue. So it's kind of a dramatic example of problems that are intrinsic, related to the selection of materials. I know that turtle ponds don't have water gushing and spraying in ways that we expect fountains to, but nonetheless, this is one of those 14 fountains. It's actually really important to our campus because it is a time that people reflect on have a moment of reflection during their busy day. The problem was that this was not recirculating water. It was water that entered the pool and then just sat there. And as you can see, there was quite an issue with silt, and the poor turtles are loaded with silt. And so from time to time, it needed a major effort to do the cleanup. It's now been changed, and so there's less of a problem. It's jointly maintained by Biological Sciences, the building you see in the background, who care deeply about the turtles, as we all do. And then another issue in Texas, we are in serious drought conditions, and so we are now, in 2008, a lot of the pipes were replaced on fountains, and that saved a lot of water. We are now down to running this fountain and Littlefield an hour a day, and that is to just keep all working parts going and to reduce algae and the like. But it's hard to think of fountains that spray copious amounts of water when you're in extreme drought conditions. And then finally, I'm in the School of Architecture. We had a design competition, and we have an area right in front of the architecture school that was basically paved over in the 1960s to stop the activity that was going on in the West Mall. I think there was a lot of protest activity, and so they basically paved it over, and there's a pretty dry fountain there. School of Architecture sponsored a design competition that was available to architecture students and art students, landscape architects, and the winner created this design. It's a series of concentric rings. The outer ring has a bench, the inner a water wall, and there are cattails in the center. Have a close-up to kind of show you. And of course, we hope that this will be realized. No Texas photo rendering is complete without the cowboy hat, I guess. But I think this would be a wonderful addition to our campus. I'd like to end by saying thank you to NCPTT, to the folks at the Nelson Atkins Museum of Art, to Martin Burke, and from my campus, Lester Felder and Charlie Cromartie, who were really helpful. So thank you very much.
We'll start with Martin, and then we'll go back to James.
The Littlefield fountain in the 1932 photograph showed a lush selection of
Right.
water plants,
Uh-huh.
lotuses and lilies. Was that actually intended in the initial design?
It was not intended in the initial design. I think that there was a time period when that was seen as being attractive, and then a number of years later, with problems that ensued by that, it was decided, maybe we better go back to the original design intention.
So the original design did have a series of sprays?
Right, absolutely, including, and this was when I talked to Lester Felder, he actually got most excited about letting me know that he had found a way to return the spray coming from the seahorse's nostrils. That made him happiest. It's like, well, good, Lester.
In the back?
Because you're using, or in drought conditions, do you guys use reclaimed or gray water for your fountains at all?
Not, well, with the turtle ponds, it is collected water. The others, they collect water from the heating cooling systems, and some of that is used in fountains. And then there's an elaborate system to recirculate. We really have to be very careful these days. There's even a restriction, in sort of looking at the UT website, you think, okay, well, what's been written about fountains on our campus? And I found, water restriction fountains, and realized that it was the water restrictions on drinking fountains. And I thought, this is severe drought. Anyone else?
No.
You brought up the issue of graffiti,
Uh-huh.
and it occurs to me that perhaps, not so much my water feature, but maybe other people's water features or what goes around the water features would be susceptible to graffiti. And at LACMA, we've been playing with we used a variety of anti-graffiti coatings, because many of you probably know we have this great rock that is an
Yeah.
installation. And so the rock is a gigantic granite rock that comes from a quarry in the San Bernardinos, and it is attached to a ramp, concrete ramp. And the coating that we actually put on the rock itself is a kind product called PSS 20. And we've done quite a bit of testing with it, and it's a very, very impressive material. I'm rarely impressed with some of the materials we use, but this one is really rather remarkable. So I think that'd be a good tidbit for
Right.
people thinking
Well,
about
and
that.
let me just add to that we have 20th century and 21st century, we have a new, we have a collection of 20th century sculpture and are acquiring new sculpture. We have a new Saul LeWitt piece. I talked to Mark Gilbert,
I'm sure.
and we sort of traded information, and we did a series of tests, and we like the kind product best.
Yeah.
And are in the process of, next week we'll probably be applying that. Now, I have back and forth conversations with Kine, because and for all of the, it's a polysaccharide, it's a sacrificial coating that is removed by hot water. And in Texas, in our fountains, we've got hot water. And so the thought would be, if we use it around fountains in our part of the world, we want to make sure that the water itself didn't compromise the coating.
We actually have, and you might have learned this from Mark, we have the concrete ramp itself. We put Prosoco, after his discussions with you, we put Prosoco on the walls. The Kime representatives, because we wanted to use the Kime on the ramp itself, and they said not to use it because even in rainwater
Slippery.
it can get slippery
Yeah,
and slimy.
right.
Now, I did all the testing of it initially in the lab with, and he and I are publishing this very shortly. The trick to the Kime, the real trick is it is invisible to a certain point. Then it starts to become a slight sheen, and there is practice required on getting it the correct application thickness. If you put it in hot water in the sink at 60 degrees, yes, it will slime off. What we were using outside, of course, was a hot water pressure washer. And I measured that just recently. What is that temperature coming out of that nozzle? And in fact, it's just below 60. So what you really get 60 degrees C. So what you really have is when you're, you put down all of your kind, you let it sit for a while, then you egg it, you know, spray paint it, whatever you're gonna do. Then when you come back, you literally have to, you're swelling it and then you're sort of chipping it with the pressure, that pressure washer. But if that kind isn't really just so you can barely see it, graffiti will go right straight through it. But when it doesn't get through it, it comes off beautifully.
Right. And it's a good point for all of us who struggle with graffiti.
Yes.
Thank you, Fran.